Hello there and welcome to the series of videos that's going through the content of A-Level Maths. Here we're looking at the exponential modelling section so we can answer questions from exercise 14c. So e to the x is used really commonly whenever you've got rates of change that are model an exponential function. So for example here, the density of a pesticide in a section of field p milligrams per meter squared can be modelled with the equation p equals 160 e to the minus 0.006 t. So the rate of pesticide is going to be decreasing, I can see, because of the negative symbol here. It's going to start at 160. So in the case where t is the number of days since the pesticide was first applied, estimate the density of the pesticide 15 days. Interpret the meaning of 160 in this model. So let's have a go at these two questions here. So estimating the density of the pesticide after 15 days, let's plug in the value for t equals 15 and use the calculator to do the rest, and you get 146.2 milligrams per meter squared. Okay. Alright then, so the next question here is interpret the meaning of 160. Well, when t is equal to 0, the power on this e is going to be 0, so e to the power of 0 is equal to 1. So the 160 refers to the amount of pesticide in the field at day 0. And that's going to be the case for no matter what exponential model you have. The number that's at the front is going to represent the value of whatever you're looking at day 1, or at day 0 rather. Okay, so using t equals 0 implies that no time has passed, so therefore 160 must be the original amount of pesticide sprayed in the area. Let's have a go at a few more questions then. So find dp by dt and interpret the significance of the sign in your answer to part C. And then sketch the graph. So let's differentiate then. So we times by minus 0.006 to the front, and we get minus 0.96 e to the minus 0.006 t. Okay, so that's dp by dt, that's that question done. For part D, the sign here is negative, which means that as the rate of pesticide is going to be decreasing with respect to time. So as time goes on, the amount of pesticide in each meter square of field is going to be decreasing. So decreasing slope, so therefore the amount of pesticide in each meter square is going to be decreasing. So what does this mean for the graph? Well, it will start at 160 because that's where our graph started at. And it's going to go downhill. It's going to have a negative gradient because that's what the gradient was showing us. Okay then, so have a go at this question here then. Just to make you aware, it's e to the minus t over 12 rather than just e to the power of t over 12. Right, pause the video and have a go. Right, okay, let's have a go at question 1 then. So the value of the car is modelled by the formula v equals 20,000 e to the minus t over 12, where v is the value of the car in pounds and t is the age in years from new. So part A to this question here is state the value when new. So when it's new, the amount of time elapsed will be 0. So therefore v is going to equal 20,000 pounds. Part B, find its value to the nearest after 4 years. Well, what we have to do there is grab our calculators and just plug in the value of t equals 4. So v is going to equal 20,000 times e to the minus 4 over 12, or e to the minus third. So that's going to be 20,000 times e to the minus 1 divided by 3. So that's going to be 14,331 pounds to the nearest pound. Part C here is sketch the graph of v against t. Well, what's going to happen here is as the power is a negative sign, I know that as t increases, the exponential here is going to decrease. So our starting value is going to be 20,000, and it's going to decrease over time and tend towards 0. So we do get exponential models that do increase as well. You've just seen 2 examples here where they decrease. Yeah, so this is what we're going to use exponential graphs for in real life. Okay, pause the video and have a practice at questions from exercise 14C. These questions do come up quite frequently in terms of using exponentials in real life problems, so make sure you've had lots of practice and practice until you're perfect at them, not until you can just do 1 or 2. Right, persevere through the difficult questions and ask your teacher for help. Thanks for watching.